Unit 2, Matter and Energy. An introduction to the classification of matter. All the stuff in the universe can be classified into two categories: matter, or there is energy. You have probably already learned that matter and energy are related to each other by Einstein's equation, E equals mc squared, where E represents energy, m represents mass, and c represents the speed of light. For now, we're going to forget about energy and focus on matter. As you know, matter is anything that has mass and takes up space, or in other words, has volume. This is a very broad definition, so let's break it down so we can understand the different types of matter. One way we can classify matter is based on purity. Most of the matter in the universe is classified as a mixture, and a very small amount of matter is found as a pure substance or just substance. Let's take a closer look at pure substances. A pure substance is a type of matter that has a uniform and unchanging composition throughout. That is, a pure sample has the same set of physical and chemical properties for all samples of that substance. Pure substances can be separated into two categories. To understand these categories, we must think about small particles. The first type of pure substance is called an element, and the second type of pure substance is called a compound. Both elements and compounds are considered to be pure substances because we cannot break them physically down into any other type of matter. Also, their composition is uniform and unchanging throughout. A particle diagram is a model of matter in which colored balls are drawn to represent atoms or molecules. This is an example of a particle diagram for an element, and this is an example of a particle diagram for a compound. Notice how in both particle diagrams the composition or type of particles is the same throughout the sample. Now let's look at mixtures. Mixtures are a physical combination of two or more substances. Since a mixture is a physical combination, each component retains its own unique properties. This characteristic allows for the separation of the mixture's components by physical means such as filtration, distillation, and chromatography. There are two categories of mixtures. The first type of mixture is a mixture where you cannot see the different parts of the mixture. We call this type of mixture a homogeneous mixture. The prefix homo means the same, and so these mixtures appear to be the same throughout. That is, you cannot see the different components of the mixture with your eyes. A good example of a homogeneous mixture is a glass of tap water. Tap water has many different substances that are mixed in it. However, the glass of tap water appears to be perfectly clear and the same throughout. The other type of mixture is called a heterogeneous mixture. This type of mixture is one in which you can actually see the different components. The prefix hetero means different, so components look different throughout the mixture. An example of a heterogeneous mixture is muddy water. When you look at muddy water, you can see the rocks, the dirt, and other components that make up the muddy water. This is an example of a particle diagram for a mixture. Notice the two different types of particles that make up the sample. Look at the samples of matter in the four containers. Try to classify the samples as a substance or a mixture. Then classify the samples as an element, compound, heterogeneous mixture, or homogeneous mixture. Pause the video now, and after you have classified the samples of matter, restart the video for the answers. Now that you have classified the samples, let's go over the correct answer. The first sample is a substance because it has the same particle throughout. It is an element. The element is hydrogen, and the particle of hydrogen is made up of two identical hydrogen atoms. The second sample is also classified as a substance. The particle is made up of two different elements chemically combined, which is shown by the hydrogen atoms touching the oxygen atoms. These particles are particles of water. They are called molecules. This is an example of a compound. The third picture is a homogeneous mixture. This is considered to be a homogeneous mixture because there are two different types of particles that make up the sample. There is hydrogen molecules and oxygen molecules. It's considered to be homogeneous because it is a mixture of gases, and gases are always considered to be homogeneous. The fourth and final picture is also a homogeneous mixture. It is also made up of oxygen molecules and hydrogen molecules. In the gaseous phase, it is considered to be homogeneous. Notice that the two mixtures do not have the same composition throughout. Okay, in the first one, you have more oxygen than hydrogen. In the second one, you have more hydrogen than oxygen. the percentage of composition is not the same in the two samples.